B-sides? I can't hear you. How are you going? All right, there you go. That's the energy we need. Yeah, this is actually my second B-Sides New York talk. I did the last one in 2018, so it's been a while. I feel kind of old, but it's okay. Good to be back. Today I want to talk about cloud attack paths, specifically within the Microsoft Cloud ecosystem. I think that we are seeing an important trend in the past breaches where attackers are going after cloud environments and they're not using malware. They're not touching endpoints. There's no EDR alerts. And I think that's interesting because in the past 10 years, we focused so much on deploying EDR on all our endpoints. But now attackers, they don't even care because now they're going directly after cloud APIs using tokens. And I think that's important. And I think we as security practitioners, both red teamers who are trying to find vulnerabilities for the customers and blue teamers who are trying to defend networks, we really need to understand cloud attack paths. We really need to understand how they're created, how we can create lab environments, how we simulate end-to-end attack simulations against them. What is the telemetry that when an attacker traverses a cloud attack path, it generates, so we can create detections, we can validate our security posture. So that's my goal today, actually. My goal is to enable you guys with practical tools. I only have a few theory slides, but then I want to show you demos of two open source tools I've built that will allow you to create attack paths on your own and to simulate them, and you can generate telemetry, learn from them. So that's my goal today. Hopefully you'll enjoy it. Just a really quick introduction. I'm Mauricio. I'm originally from Peru. I've been in New York City for 13 years now. It's been a while. I work at Microsoft. I run a security research team, and I'm still on Twitter or X if you are still there. And on my GitHub page, I have links to my talks, tools, and the slides for this talk will also be out there if you want to get them. But that's it. Let's move on. I first wanted to start with a quick definition of what I think attack paths are, at least from my perspective and in the context of this talk. Attack paths are, for me, the path or the chain of steps an adversary takes by abusing compromised identities and abusing legitimate permissions to reach a goal. An important piece here is that I'm not talking about vulnerabilities or 0 days or exploits. We're talking about legitimate identities, legitimate permissions, and targets and resources with these identities. And an attacker is able to identify those after compromising one and then navigating those attack paths to achieve a goal, which could be exfiltrate emails or read a database or install ransomware. How are attack paths created? And I think the three main components for attack paths to be generated are the who, which are the security principles, the identities. These are the users, the app registrations, the service principals, who are actually compromised by attackers one way or another. Then the what, which are the permissions, the entitlements. And this could be, within the cloud world, we have Entra ID roles, we have Azure RBAC roles, we have Graph API permissions, specific API permissions. So these are the entitlements or privileges that these identities have. And finally, the targets. That's where attackers are going. These are, your tenants, your mailboxes, your Key Vault services, your databases, your OneDrive files. These are all the targets that attackers, by abusing those legitimate permissions, by compromising those identities, they're able to get to them. So let's look at a really simple example of what an attack path could look like in the Azure world. Let's say we have a user Bob here. Bob is a compromised user. An attacker has compromised their account either through password spraying or adversary in the middle or token theft. Whatever technique they use. Let's say that this attacker has elevated their privileges to be able to compromise an app registration within Entra ID, right? And of course, this app registration really runs as a service principal within the Entra ID world. And if that service principal has an Azure RBAC role, perhaps, let's say the VM contributor role, this role actually allows you to manage VMs and execute code on them. So if an attacker is able to traverse this to this point of the attack path, now they're able to execute code on VMs. And let's say there's a VM there, which we'll call Gibson 01. And this VM has a managed identity, which is a way how in Azure resources have identities and have the ability to connect to other resources. If you can execute code on a VM, you can actually steal the token of that managed identity and become that managed identity. So if that's the case, and if that managed identity has access to a storage account that has sensitive files, we have now created an attack path where if this user Bob is compromised, an attacker is going to simply abuse the legitimate permissions and the connections within this cloud to be able to exfiltrate those sensitive files from the storage account. And of course, as you can see, we're not talking about vulnerabilities, we're not talking about exploits or 0 days. We're talking about configurations that are going to arise as an organization moves to the cloud. As we have more users and more resources, we're creating more and more configurations that just happen, we forget about them, and they're still there. And another important concept to talk about is how are attackers traversing the attack paths, right? So how are they moving to this attack path? I think we can call those attack primitives. Those are the capabilities that could be a configuration, a credential, a permission that an adversary will abuse within an attack path to move from one step to another. And these are, again, just legitimate actions that can happen in a legitimate workflow within an organization. For example, think about mailbox access, right? When an attacker compromises a cloud, let's say an M365 environment, one of the goals may be to exfiltrate emails. Well, how can they exfiltrate emails? There's multiple ways. For example, if they're going to use the Graph API, there's a permission called mail.read that allows you to read email. If you're going to abuse the Exchange Web Services API, EWS, there's another permission that allows you to read emails, right? So all attackers have to do is find that right identity that has the right permission to then abuse this legitimate feature of the Microsoft Cloud or 365, which is to read emails programmatically, and then abuse that and add that step as part of your attack chain, right? So these are the attack primitives. We're not talking about vulnerabilities. We're just talking about legitimate features that can be abused by attackers given the right circumstances. How are we in time? Okay. All right, so now that we understand what attack paths are, now let's move to the fun part. How can we create these attack paths? So how can we use lab environments to create these attack paths so we can explore them? Well, of course, going back to the mental model that I was sharing before, this is what we need. We need principles, we need permissions and entitlements, and we need targets to go after. So let me introduce you Batcher. Batcher is a tool that I wrote a couple of years ago that actually populates Entra ID Azure environments by creating identities, resources, entitlements, permissions, and then it allows you to configure attack paths within those environments so that you can explore how attack paths are created, you can simulate the attacks, and you can learn from them. That's the main goal. You're going to release a new version today. After this, I'm going to merge that PR request, which has a lot of the features that we're going to share today. So, Batcher really has a really simple configuration file, so you can define basically how you want your lab environment to be constructed. So you can define how many users and applications, service principals, groups, administrative units you want created. Batcher is going to randomly generate new names every time, new group names, and it's going to randomly assign them so we can try to create the idea of a fake environment, right? Then it also supports creating Azure resources. At the moment, we support 4, or 3 really, virtual machines, storage accounts, and key vaults. So you can define how many you want. It's going to randomly pick names, create them, put them in random resource groups. So that gives you that baseline of what looks to be a real environment with identities, resources, permissions. Then we move on to the attack path area. This is where you can configure your attack paths. And at the moment I support, I think, 3 privilege escalation techniques and multiple parameters, and they're all described on the wiki. But essentially on this second part of the YAML file, you're essentially defining what are the attack paths that I want in this environment, and Batcher is going to inject them for you. So we're going to have a look at 4 attack paths, and we're going to create 4 attack paths in our lab environment with Batcher in the demo. This first attack path is a pretty straightforward one. We have a user Bob again. I like the name Bob, I guess. Bob is the owner of an app registration. And that's the first attack primitive. If you're an owner of an app registration, you can actually manage it. You can actually add credentials for that app registration. And if you're able to add credentials to it, then you can authenticate as it. So you effectively escalate in privileges to a service principal. So this user Bob, who doesn't really have any other permissions than being the owner of this app, can effectively compromise the identity of that service principal. So through this attack path, Bob escalates privileges to this Acme service principal. And if this Acme service principal has this privilege role, which is an entry ID role, this role actually allows you to promote anyone to global admin. So through this attack path, Bob could become a global admin or assign a global administrator role to any other user, right? So effectively escalating privileges and taking over the tenant. That's one attack path. Second attack path has the pretty similar first steps, but the only difference is that on the last step, the compromised service principal doesn't have an entry ID role, but rather has a Microsoft Graph API or API role, which is the app role, assignment, read, write, all. This API permission actually allows you to assign yourself or any other principal any permission. So you can promote yourself again, give you another permission, and then finally make it to global admin as well. So that's our second attack path. Pretty similar to the first one. The only thing that changes is that last permission. Now let's move on to the third one, which is slightly different. Now we introduce a key vault into the mix. So let's say that we user Paul has somehow permission to read a key vault. And if this key vault has a secret for an app registration that runs as a service principal, then once again, through that key vault, you can escalate privileges to that app registration. And in this case, the mail.read permission, guess what, allows you to read emails in an environment. So you could exfiltrate emails from that tenant. And the most interesting and the most complex attack path that Bachelor supports at the moment is this one where we have a VM now. Now we have a virtual machine. If the user, Tom, can execute code on that VM, and if that VM has a managed identity, and if that managed identity has a special permission against another resource, in this case, like a storage account, and in our simulated attack path, if that storage account contains certificates for another app registration, then our attacker can traverse this attack path by first running code in the VM, stealing that managed identity token, abusing that managed identity token to read a storage account, exfiltrate the certificates, use the certificates to authenticate as a service principal, and effectively become that service principal. And then finally, the permission file that reads all allows you to read anyone's file, OneDrive or SharePoint files. So this is the fourth attack path. All right, so let's move on to the first demo real quick, and hopefully this works out here. Great. I was afraid this is not going to work, and let's make sure we have the right quality. But essentially what I'm sharing here is, we have a live tenant. Hopefully this shows up. It's pretty empty. We have no users, no groups, no resources, and we have our tool here, Batcher, which is again open source. You can download this and do the same what we're going to do. And then you have this configuration file, which will define what we're creating in our live environment. In this case, I'm going to create 50 users, 20 applications. You get the idea. Those are randomly generated identities. And then you're going to create 10 resource groups, 10 key vaults, a few VMs, a few storage accounts. And then on top of that, we execute those 4 attack paths that I described on the slides. We're describing them here with YAML. And of course, each of these parameters means something, and you can go back to the wiki to learn what they are. And all we have to do is simply call the build command of Batcher. And Batcher is going to use Terraform on the background to start creating these things, creating attack paths. And of course, we can see here everything that's going to be created by looking at this Terraform file here. And you can see exactly, here all the users that Batcher is going to create, all the entitlements, attack paths, permissions. So I'm going to fast forward a bit because we don't have a lot of time left. And Batcher finishes. It takes from 5 to 15 minutes depending on how many things you're creating. And we inspect our tenant. Now we see it's populated with these 50 users, randomly created identities. He has groups, he has entitlements, he has permissions, all the fun stuff. But now let's take a look at a couple of those attack paths that were created with Batcher. So if we go back to the Terraform file that described everything that was going to be created, we can go back and actually see that each attack path has an ID. So we can inspect those attack paths that we just created with Badger. So let me inspect one of them so you kind of like see the idea of how the attack path looks from an Azure perspective. So I'm going to randomly pick one here, and this is the one, and I'm going to pick this app registration called Cyber Director. So this app registration, Cyber Director, if we look at it from the Azure portal, we find it, and we see that it's going to have a privileged permission. 10 minutes, okay. And that's it. That's the mail.read permission. So this permission allows you to read anyone's emails on the tenant, right? Provided that it's consented, admin consented. This app registration doesn't have any owners, okay? So how is it part of this attack path? Well, there's actually a key vault. If you look at the Terraform file, you'll see that there's a key vault name. And if we inspect that key vault, we're going to find that Badger has actually, when it created the app registration with the permission, it created a secret for that app registration, and then it created the key vault and then injected that secret into that key vault. This, again, this way we are creating the attack paths, right? So we are, and then finally, we are allowing a user, and we're going to fast forward a little bit here. We're going to give a user, a random user created from the previous steps, we're going to give a user read access to that key vault. So that's how the attack path gets constructed. Now we have a user who has a permission on a key vault, and this key vault has a secret for an app registration, and this app registration has a high level permission, and we can navigate the attack path. So with this setup, now you can go ahead and test this attack path, execute attack simulations, perhaps run Bloodhound against it, or run your security tools, like will your security tool detect this attack path. I have one more here, but I don't think I will have time to show it. But essentially, this is the one where, you know what, let's do it real quick. So there's a VM, and this VM has a managed identity that has a role assignment, and this role assignment is, oh surprise, storage blob reader. And guess what? That storage account has certificate files, and those certificates allow you to authenticate as a service principal. So that's why Badger allows you. That's how Badger allows you to create these different attack paths. All right, so let's go back to our slide. So now that we have the attack paths created thanks to Badger, how do we simulate those attacks end to end, where we start as a compromised user, we abuse all these different legitimate permissions, entitlements, and then we get to the goal? Well, I wrote another tool for that, and that tool is called MS Invader. MS Invader is an adversary simulation tool that allows you to execute end-to-end attack simulation playbooks. And guess what? It also leverages a really simple YAML configuration file, where you define a few things like you first define what are your victims, your assumed compromised victims. So you have a user here and two victim users here, and then you define a playbook with all the techniques that you want executed and under the context of which user. I think I support 30 or 40 unique techniques now, and those techniques are essentially the attack primitives, things like read email, add application secret, etc., etc. And all of this is documented on GitHub, and thanks to ChatGPT, I have pretty good documentation now. So let's go back to that attack path. Remember that first attack path that we saw on how to become escalated privileges to global admin? Well, now we're going to execute it. And, this is our playbook. This is our MS Invader playbook, right? So let's say we have a compromised user. As that compromised user, we're going to start. What does the attacker do the first time they get in? They do enumeration. So we're going to enumerate users, enumerate groups, enumerate applications. The cool thing is that all these enumerations through the graph are going to create logs. So as we execute this attack path, we can validate if our security posture would have detected this type of enumeration, right? So that's the main goal of MS Invader, to generate telemetry that allows you to validate your detections or to identify those blind spots you have in your logging coverage. So once we finish with enumeration, we move on to escalating privileges. We're going to add an application secret because this user is the owner of the app, so we can add a secret to it. Then we authenticate that as that app registration or service principal. We assign ourselves a new role that will allow us to become to be able to assign any Entra ID role. We're going to create a new user It's going to be Lex Luthor, and then we then promote that user to global administrator. And then this is the third attack path, which involves a key vault, right? And if you remember, the attack path, the attacker can read the key vault, read the secret, authenticate a search principal, and abuse the search principal. And this is the playbook that MSImator is going to run for this. So we're not going to go through that because we only have 5 minutes. I'd rather stick to the demo, which is cooler, and you'll find it more interesting, I think. I hope. At least I had fun doing it. Alright, so this is the same playbook that we just created with Batcher, right? The same attack path, right? So we have this user here who is the owner of an app, and this app has this app role assignment or this Graph API permission. And as you can see, there's no user called Lex Luthor or Lex in this environment yet. So we have our MSImator playbook, and I'm not going to go through the details. And we have our MSImator tool, of course, ASCII art, you must have it, and the playbook here. I'm not going to go through the details of what the playbook does, but documentation, once again, thanks to ChatGPT, is pretty good documented there on GitHub of all the different features and the techniques that it supports. But essentially, you just describe the playbook, the end-to-end simulation, attack simulation that you want against this environment, and then you just start running it. In this case, we're going to assume that this user is compromised, that we have their password already, and there's no MFA. So it starts running. It takes a few minutes, but we're going to just fast forward here, interest of time. By the way, all these videos are also going to be on my GitHub, so if you want to watch them later, you can. For each step, it's going to give you details of what it did and the results of each step. As you can see here, it added a secret. It basically using the Graph API and the ARM API to do a bunch of stuff. But if we go back to our app registration, we now see that this app registration, instead of one, now has 3 roles, which were part of the attack path, where it abused this permission to grant itself other roles. And if we see here, we refresh the certificates and secrets, we see that there's a new one that wasn't there before, because as part of the attack path, we added a new one using the API programmatically. And finally, we do find a user Lex Luthor here, and now guess what? He's a global administrator. So now this tenant has been compromised thanks to this attack path and thanks to MSImator allowing us to do this in an automated way. Let's move on to the next playbook where there's a key vault involved. So this is the key vault that has a secret, and as you can see, this secret, this key vault has a user has a permission against this key vault, and that's the user that we're going to use as our assumed compromised user with our MSImator playbook. So we have 2 minutes left, so I'll just fast forward. Here's the second playbook where we describe which are the identities that we're going to use, what are all the steps that we want to take on this simulation playbook, like things like list key vaults, add access key vault, add an access policy, read secret, authenticate, etc., etc. And finally, our last step here is actually we're going to exfiltrate emails from the tenant. So we run the second playbook, starts doing its thing, and we see towards the end that it actually exfiltrated emails. You'll see towards the end the emails, see those emails that you read from those 2 mailboxes. It actually, used the Graph API and abused those permissions to exfiltrate emails, just like real attackers do. And as you can see here, there's a new access policy that was added by MSImator, and that's how the attacker was able to read secrets from this key vault. And I think, yes, I have like 30 seconds, so we'll just wrap this up. And yeah, those are the tools, guys. You can use them, open source. My goal is to enable you guys to learn about attack paths, create them, simulate them, look at the telemetry. You can get an Azure subscription with a credit card, so just don't go crazy on the resources. As long as you delete them, then you should be fine. But yeah, go out and try them, and thank you very much. These are some resources from like researchers that post a lot of Enter ID and Azure, and so just if you're interested about this topic, I recommend hitting those. They're going to be on my slides. But thanks a lot. Hope you liked it. Thanks. Thank you.